Hello everyone, my name is Zhabbarov I am a graduate student from Samara State University, and a topic of my presentation is quasi-linearization method for the solution to the problem of a plate with central circular hole under creep regime. First, I will begin with an overview of quasi-linearization method. Nowadays, modern computers and new technologies can provide the numerical solution of system of a nonlinear ordinary differential equations given a complete set of initial conditions with accuracy and high speed. Physical, economic, engineering, and biological problems are reduced to the problem of solving boundary or initial value problems for ordinary differential equations. It's very important to find a complete solution or a closed form analytical solution. Hence, the great challenge to the mathematician is to find ways to construct the requisite theories and formulations, approximations and reductions allowing to obtain analytical solution. In mechanics, physics and mathematical physics, the underlying equations are nonlinear partial differential equations, differential integral equations, differential difference equations, and equations of even more complex type. One of the prominent approach to reach the analytical solution is the quasi-linearization method. Quasi-linearization achieves this objective by combining linear approximation techniques with the capabilities of the digital computer in various adroit fashions. The approximations are carefully constructed to yield rapid convergence and monotonicity as well in many cases. The quasi-linearization method has gained much attention from many researchers. It's well known that the method of quasi-linearization offers an approach for obtaining approximate solutions to differential equations. This method can be combined with the lower and upper solution method. The method allows us to find a monotone sequence which converge quadratically to the solution of the differential equations. In the present presentation, the approximate solution to the problem of tension of plate with central circular hole in a power law material is studied. The quasi-linearization method is used for the analysis. A sequence of 4 approximations is obtained. It's shown that the quasi-linearization method is very effective for the problem. Let's now turn to mathematical statement of the problem and we'll see basic equations. A plate with the central circular hole is considered. The geometry is described by the polar coordinate system as shown in figure 1. Material behavior is described by Bailey-Norton law given by equation 1, where sigma E is von Mises equivalent stress and Sij is a stress deviator, and B and N is a constants. The aim is the analytical determination of stress-strain state in the plate with the central circular hole in polar law creeping materials. The equilibrium equation can be written as equation 2. The probability condition has the form 3. For a material subjected to power law creeping, the constitutive equation can be written as equations 4 and 5. Equations 6 is the boundary conditions. Let's move on. Quasi-linearization method procedure. The approximate analytical solution of the nonlinear differential equations from 1 to 5 can be derived by the quasi-linearization method. A sequence of approximate solutions is generated in the following manner. Linearization of the constitutive equations 4 and 5 leads on rearrangement to equations 7 and 8. The coefficients A and B are evaluated for the current estimate, and they are system 9. Equations 7 and 8 can be rearranged as equations 10 and 11. Combination of this system with compatibility and equilibrium equation gives system of linear differential equations 12. Let's see results. As an example, this problem solved for Bailey-Norton power law where constant n equals 5. Convergence of stress components are illustrated in figure 2. In figure 3 is shown the comparing quasi-linearization method for approximation with solution given by Runge-Kutta-Fehlberg method and solution given by Simule-Abacus soft package. It's shown that for approximation given by quasi-linearization method converges to the limit numerical solution. It's worth to note that the tangential stress reaches its maximum value not at the circular hole but at the internal point of the plate. Using Simule-Abacus, also a set of solutions for n for constant n equals to from 2 to 10 in Bailey-Norton law are calculated, and also results given by Simule-Abacus are illustrated in figure 5. Finally, conclusions. The approximation solution of the problem for an infinite plate with central circular hole under creep regime is obtained by the quasi-linearization method. For approximation of the solution of the nonlinear problems are found. It's shown that with increasing the number of approximation, the solution converges to the limit numerical solution. It's also shown that quasi-linearization method is an effective method for nonlinear problems. Thank you very much for your attention.